myself, Anamika Goyal, Assistant Professor in the Department of Computer Science and Engineering, AIML, from ABES Engineering College, Ghaziabad. Today, we'll be discussing about the introductions to design, analysis, and algorithm. In today's lecture, we'll be covering following topic: algorithm, criteria for algorithm, difference between algorithm, pseudocode, and program, then algorithm design technique and algorithm analysis techniques. Design, analysis, and algorithm. Basically, the combinations of three important keywords. First one is design, then analysis, and then algorithm. So, before going to discuss about design analysis, let's get start. First topic, algorithm. So, what is an algorithm? The word algorithm comes from the name of Persian author Abu Zafar Muhammad in 825 AD. Abu Zafar basically providing the solutions or step-by-step solutions of a basic arithmetical problem like insertions problem, multiplications problem, division problem of ordinary decimal number. After this, the algorithm words come into an existence. So what is an algorithm? It is a sequence of steps to perform a step-by-step solutions of a given problem, or we can say an algorithm is taken some input and produce some output. That is what? That is an algorithm. So to understand the concept of algorithm in detail, let us see the diagram. In this diagram, suppose we have a problem like searching problem, sorting problem, and tower of Hanoi problem, and many more problems. And I want to write an algorithm or step-by-step procedure to solve a particular problem. That is nothing but that is an algorithm. A program cannot directly writing the program. First, will program to solve a particular problem. First, we'll write an algorithm and then it convert into the program. So, after writing a program, programmer will convert it into program. So what is program? It is a set of sequence of instructions. Set of sequence of instruction is nothing. It is a program. When we convert algorithm into program, we also need some data structures like heap, linked list, stacks. Now, what is data structure? Data structure is a way of organizing a data to perform an operation in an efficient manner. So basically, with the help of data structure, a programmer convert algorithm into a program set of sequence of instruction. After that, this program will given to the computer, which takes some input and produce the output. This is all about the concept of an algorithm. Now, the criteria for an algorithm, or we can say it is a characteristics of an algorithm. So if I'm talking about the characteristics or criteria, so we basically consider the 5 points. First one is the input of an algorithm. If I'm talking about the input, so what is input? An algorithm use values from a specific set is called input. It should be 0 or more well-defined input. For example, if I'm writing a program or an algorithm to find the additions of two numbers, so in that case, the input is two number, A or B. That is the input of that particular program or an algorithm. What is an output? The output is the sum of two numbers. Like for each input, the algorithm produce values from a specific set. An algorithm should have one or more well-defined output. So the output is the sum of two numbers. That is the output. Each algorithm should contain at least one output. Suppose if I am going to write an program to print hello words. So in that case, input is 0 and the output is the printing message, that is hello world. Our third criteria is definiteness of an algorithm. It means algorithm should be clear and unambiguous. What does it mean? When we are writing an algorithm, so we just try to avoid the ambiguity in that an algorithm. Suppose I want to write a program to find the divisions of two numbers. And in that case, we take two values as an input, like A is equals to 6 and B is equals to 0 and the program division is equals to A upon B. What does it mean? It means 6 divided by 0. That is what? That is a division by 0 problem. In that case, compiler will generate an error. This is an unambiguous statement. Okay? So try to avoid these kinds of statement when writing a program. Is it clear? Next criteria for writing an algorithm is finiteness. Algorithm must terminate after a finite number of steps. So each algorithm should contain finite number of steps, and algorithm should not be infinite and always terminate after definite number of steps. Last criteria is effectiveness. To measure the effectiveness of an algorithm, we just calculate or evaluate the efficiency of an algorithm in terms of times and memory. An algorithm can be expressed in different notations like natural language, pseudocode, programming language, etc. Our next topic is what is the difference between algorithm, pseudocode and program. Basically, it's the notations of an algorithm. When we writing an algorithm in natural language or when we write a solution of the given problem step by step using natural language, that is nothing but a program. For example, suppose I want to write an algorithm to find greatest among three numbers. So when we suppose I have three numbers x, y and z, and the value of x, y, z is 10, 5, 3. And the problem is to find the greatest among three. So what is the procedure? First we'll compare 10 is to 5. 10 is greater than 5. Then is it greatest number? No. We'll compare 10 is to 3 also. 10 is greater than 3. Yes. Your condition is 2. So the greatest number is 10. Otherwise, we'll compare y to x and y to z, and last we'll compare z. So the solution of that particular problem in natural language is called algorithm. Like start, input the three number x, y, and z. Compare x is greater than y. Yes, then compare x is greater than z. If x is greater than y and x is greater than z, then the output is x is greatest number. Otherwise, the output is z is greatest number. In second case, if x is not greater than z, so what happens? Z is greater, y is greater than z. If y is greater than z, so again we'll compare y is greater than x. So we display the greatest number is y. Otherwise, the greatest number is z. I hope you understand the concept of an algorithm. Next term is pseudocode. Pseudocode is nothing but a simple version of programming code that does not require any strict programming language syntax. Pseudocode is basically the intermediary between the algorithm and program. When programmer will convert algorithm directly into the program, so it will face some difficulty, like with the help of algorithm. In algorithm not clearly mentioned where we use conditional statements, switching statement, looping statement, and all. So it is little bit tedious to convert an algorithm into a program. So to avoid this situations, programmer first write a solution in the form of algorithm, then convert this algorithm into pseudocode, and after that finally convert this pseudocode into the program. In pseudocode, basically we use some keyword like if, else keywords and loop keyword. So with the help of this keyword, writing a program will be very beneficial for a programmer. Examples of pseudocode, again similar problem, find greatest among three numbers. So what we have to do, we just input three number, input x, input y, input z, and we will compare. If x is greater than y, x is greater than z, then the output is x. Otherwise, the output is y, and the last output is z. This is the pseudocode. And the last one is the program. Program is nothing, it is a set of sequence of instruction is called program. It is strict or particularly any programming language like C, C++, Java. So to understand the concept of program, again we take same program greatest among three number using C language. In C language, first we'll include the header file stdio.h and start the main function. Then take three number as an input x, y, z using input and output function printf and scanf. After that, we use some logical operator. If x is greater than y and x is greater than z, then the output is x. Otherwise, y is greater than x or y is greater than z, then the output is y. At last, z is greater than x or z is greater than y, then the output will be Z. So this is what, this is a program. After that, our second keyword is algorithm design. What is design? So design basically a method or technique of creating an efficient algorithm to solve a problem. Here we have some common design technique. Is first one is divide and conquer approach. Divide and conquer approach, as its name show, it is based on dividing and after that combining approach to generate the solutions of a problem. In this approach, we divide the solution of a problem into three steps. First, divide the problem into a set of sub-problems, then solve each sub-problem individually and combine the solution of all the sub-problem into a solution of original problem. That is what? That is divide and conquer approach. For example, in merge sort. What is it? Divide and conquer approach. In divide and conquer approach, suppose we have a array of 10 elements. I want to sort the number of elements stored in that array. So what happened? We just divide this array into a equal number of group list of elements. So first we'll divide this problem A of 10 element into A of 5 and A of 5. Again we'll divide A of 5 is to A of 2 and A of 3. Again, we'll generate the solutions of A of 3 and A of 2 is A of 1 or A of 1. And we divide the problem until and unless each problem is act as an individual problem. After that, we'll try to solve this individual problem and finally we'll combine all the sub-problem to generate the solutions of the original problem. That is what? That is called top-down approach. This is divide and conquer approach which is used in merge sort. Our second design technique is dynamic programming. Dynamic programming is just the reverse of divide and conquer approach. It is a bottom-up approach. It is a bottom-up approach. So in dynamic programming, what we have to do in dynamic programming, basically, we just try to solve all small individual problem and then finally combine to obtain the solutions for a complex problem. That is what? That is called dynamic programming. After that, third important design technique is greedy technique. Greedy technique, it is used to solve the optimizations problem. Optimization means performance, better performance with less utilizations of resource. If I am writing an algorithm which generate the result or increase the system performance and with the utilization of minimum number of resource, that kind of solution is the best solution, optimal solution. So greedy technique is used to solve the optimizations problem. It is the one in which we are given a set of input values which are required either to be maximized or minimize some constraints or conditions. Our last topic is algorithm analysis technique. So before start the topic, first we need to know why we require algorithm analysis. Suppose I have a problem like searching problem, sorting problem and many more problems. In one problem, there are multiple solutions, right? There are multiple solutions for a single problem. So which solution will be the optimal solution? Which one is the best solution? So to find out the optimal solutions or best solution, we need algorithm analysis technique. Basically, algorithm analysis techniques are the method used to evaluate the efficiency of an algorithm. To measure the efficiency of an algorithm, we take two parameters for consideration. First one, the amount of computer time, that is nothing but time complexity, and amount of computer memory, that is nothing but the space complexity. So time complexity is a measure of running time of an algorithm as the problem size increases, and space complexity, it is a measure of memory uses of an algorithm as the problem size increases. So when we are talking about algorithm analysis, so after writing the solutions of writing an algorithm or solutions for a given problem, we just evaluate the solution with the help of algorithm analysis technique in terms of time or space complexity. Basically, there are three types of analysis present. First one is the best case, second one is the worst case, and third one is the average case. To understand the best, worst, and average case, again, we'll take an example of linear search. Suppose I have an array of 5 elements, 5, 2, 3, 1 and 8. This is what? This is an array of element which stored 5 data items, right? In first case, that is the best case. What is in best case? Suppose I want to search a desired item I into the available list of array, for example 5. If I want to find data item value 5 into an array, in best case, when we'll start the search, it will get in first attempt. Okay, that is what? That is best case. What is the worst case? In worst case, suppose I want to search data item 8 or data items 9. In that case, if I want to find that particular data item, first we'll compare 8 into 5, match not found. Then 8 into 2, match not found. 8 into 3, match not found. 8 into 1, match not found. Finally, 8 into 8, match found. So, if there is a 5 number of element in an array, so total number of steps will be 5. And if I want to search 9, so this data item will not present in the list. So this is the worst case of an algorithm. What about average case? Suppose I want to search a data item, the value is 3. In that case, the data item which I want to search in the list of array will exactly present the middle positions of an array, that is 3. That is what? That is average case complexity. I hope you understand the concept of an algorithm analysis, why we require. These all are the reference which I use in my presentations. This is all about in my side. Thank you for watching my video.